Hello, this is Mr. Huber. In this lesson, we're going to learn about adding and subtracting polynomials. So we'll talk about what a polynomial is in a minute. First, a monomial. So it sounds similar. Poly means many, polynomial. Monomial means one. So monomial is something that has one term. Okay? It's a number, a variable, or the product. So multiplying numbers and variables. We see some examples here. So a number by itself is called a monomial. 3x, that's the product of 3 and x. It's the product of a number and a variable. That's a monomial. Same down here. We can have more than one variable. We can have them to powers. That's fine. We're multiplying some numbers and some variables together, and that makes a monomial. Okay? The degree of a monomial. The degree of a monomial is the sum of the exponents of the variables. So here where there's no variable, this would be like x to the 0 power or something like that. So that's the degree 0. When it's a constant term, a constant is just a number with no variable. Here we have 3 to the x. X is to the first power, so the degree is 1. Here a is to the first, b is to the second, so we add that, 1 plus 2, the degree would be 3. And here the degree is 5, m to the fifth. So the degree, again, is the sum of the exponents of the variables in the monomial. Let's talk about what makes something not a monomial, right? A sum or difference. Okay, if I'm adding or subtracting, that is not a monomial. If we have a variable in the denominator, that is not a monomial. This would be the same thing as having a variable in the denominator. When we have a variable to a negative exponent, remember negative exponents, that would move it to the denominator, right, as a reciprocal. So this would be the same thing as 1 over x. So can't have a variable in the denominator, can't have a negative exponent, okay? Or a fraction exponent, right? So 4 to the a, right, that's why it says a whole number, right? 1/2 is not a whole number, right? 4 to the a, we can't have the variable be the exponent, right? So those are things to look for that make something not a monomial. Not adding or subtracting, no variable in the denominator, negative exponent or fractional exponent, and no variable in the exponent itself, right? But a monomial is numbers and variables multiplied together. Right. A polynomial, poly means many, so it's many monomials put together with addition or subtraction. Subtraction is like adding a negative. So we say sum, but that's the same thing as subtracting a negative would be, or excuse me, adding a negative would be the same as subtracting. So sum or difference of monomials. Each of the monomials that are added or subtracted is called a term. So if we come up here, 5 plus x, this is an example of a polynomial. It's got two monomials added together. 5 is a term, x is a term. Those are called the terms of the polynomial. Right? The degree of a polynomial is the greatest degree of any of its terms. So we're going to see some examples of that in a minute. But we can find the degree of each of the monomials, each of the terms, and we find out whatever the greatest degree of those is, that's the degree of the whole polynomial. Okay? Standard form for a polynomial is writing the polynomial so its terms are in order from highest degree to lowest degree. So we see an example down here. X to the third, x squared, this would be x to the first. This is a constant term, x to the 0. So our exponents go in decreasing order. Highest exponent down to lowest exponent. That's standard form. And the leading coefficient, okay, the leading coefficient is the coefficient at the very front when it's in standard form. We talked about the degree being the greatest degree of any of its terms. So the degree of this whole polynomial would be 3. Right? The degree of this monomial is 3, the degree of this monomial is 2, degree of this monomial is 1, and of the constant term is 0. So the highest of those degrees would be 3. So it's a polynomial in standard form with degree 3, leading coefficient of 2. That's called the constant term. That's not changing. There's no variable associated with it. So there's a lot of terminology and vocabulary here. As we see a lot of times, know the vocabulary, the terminology, so you know the language of math. So we can use it properly, we can understand it when we see it in certain situations. And now we're going to look at how to use some of this terminology. But know what a monomial is and a polynomial, which is a sum of monomials. Okay? Know about how to find the degree of a monomial. And then the highest of those degrees in a polynomial is the degree of the whole polynomial. Understanding standard form and what it looks like to write something in standard form. We typically want to write our form in that standard way so that we're all doing it the same. All right, let's see some example problems here. we want to write this polynomial in standard form. So we have a polynomial here, we want to write it in standard form. Then we're going to identify the degree and the leading coefficient. The degree and the leading coefficient. So let's start by writing it in standard form. So we need to find the highest degree monomial. That's negative 7 x to the third. Make sure the negative 7 it stays at the front. It's a negative in front of the 7. So when we write this, negative 7x to the third. Then we look at the next two terms. We have the 15x would be the next because the constant term doesn't have any variable at all, so its degree is 0. So I'd have plus 15x and plus 9. That would be standard form. Okay. The degree is 3. Right? The degree is 3 because it's the highest degree of any of the monomials. And the leading coefficient would be negative 7. Right? Negative 7 right here, the leading coefficient is the coefficient in front of the whole polynomial when it's in standard form. So make sure you get it in standard form first. We don't want to say the leading coefficient's 15 just because that's at the front here. Get it in standard form, then identify those different aspects of the polynomial. Now let's look at identifying if something is a polynomial and then finding its degree and classifying it by the number of terms. All right, so let's see the first one, 9. So the number 9, okay, it's a monomial, okay? So that makes it a polynomial, right? It's just a single term, that's fine, that's a polynomial. A monomial is a polynomial. And its degree is 0, okay? And one term, which we call a monomial. So know the terminology, right? One term makes it a monomial. Right? The next example, we have 2x squared plus x minus 5. So it's 3 separate monomials. This is a monomial, 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 all added or subtracted, right? This is like plus negative 5. So we're adding and subtracting terms. That makes it a polynomial. The degree, okay, the degree is 2. The degree is 2, our highest exponent there of any of the individual monomials, highest degree of any of the individual monomials. And it's got 3 terms. And there's a word for that. It's called a trinomial. Okay, a trinomial has 3 terms. So again, know that terminology. We talk about a trinomial, we know it has 3 terms. Next, we have 6n to the 4th minus 8 to the n. Not a polynomial. All right, not a polynomial. Why do you think it's not a polynomial? If you think back to what we talked about, things it can't have as a variable as the exponent. So 8 to the n. So because of that, that makes it not a polynomial. Then next we have n to the negative 2nd minus 3, also not a polynomial because we have n to the negative 2nd. Can't have a variable to a negative power. Right? In our last example here, 7bc to the 3rd plus 4bc to the 4th c, or excuse me, b to the 4th c. All right? So let's find the degree. It is a polynomial. We're adding and subtracting monomials. This is a monomial. It's terms multiplied together. A monomial, terms multiplied together, and we're adding them. So we're adding 2 terms together. So it's got 2 terms. We'll talk about that here in a second. The degree, okay, this has a degree of 4. This has a degree of 5. So the degree of the whole polynomial would be 5. And it's got 2 terms. Let's see if you know what the word is for 2 terms. If a monomial has 1 term, a trinomial has 3 terms, a binomial has 2 terms. So know the terminology there. Binomial, something with 2 terms. Monomial, binomial, trinomial. When we get past it, we just say 4 terms, 5 terms. There's not words we're going to put to those. But you should know those 3 pieces of terminology. 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial. How to find degrees, determine if something's a polynomial, and find that information from each of those. Okay, let's look at some more examples in a moment after we take a little Olympics break. When did the Winter Olympics start? The Summer Olympics were the first Olympic Games. The Winter Olympics started after that. It actually began starting out as a prelude to the Summer Olympics. Germany was going to host the Summer Olympics, and they decided to hold what they were calling a Winter Sports Week to kind of get prepared for it, prepare the city and the country for coming together for an Olympic Games. It wasn't called Winter Olympics, they just called it Winter Sports Week, but it was canceled because of World War I. Then the IOC thought, hey, that was a pretty good idea Germany had, maybe we should try that. And so they started International Winter Sports Week in advance of the Summer Games in France in 1924. And then from there on, it became known as the Winter Olympics after it went off successfully before that prelude to the Summer Olympics in France. So it started in 1924. It's the International Winter Sports Week and turned into the Winter Olympics we know today. Let's talk about adding and subtracting polynomials. That was the title of this whole lesson. So we're finally getting to that. We had to understand the terminology. Again, there's a lot going on there to understand what we're talking about when we look at monomials, polynomials, degrees, coefficients, those types of things. What is a term? And here, what is a like term? Okay, so a like terms have the same variables to the same powers. So like x squared and x squared would be the same variable to the same power. X squared and y squared, not like terms because they don't have the same variable. X to the squared and x to the third, not like terms because they don't have the same variable to the same power. So when we add or subtract polynomials, we want to add or subtract the like terms. And we're going to add or subtract the coefficients in front of them. So if we look at our first example here, right, we've got this polynomial added to this polynomial. So we want to add the like terms. So I look here, 2x to the third. I'm usually going to start, so it's in standard form when I'm done, with the highest degree exponent. Okay, so I have 2x to the third. I'm going to add that with the term over here that's got the same variable, the same power, x to the third. So 2x to the third plus x to the third. I add those and I get 3x to the third. Then I'm going to take my minus 5x squared plus 2x squared. That's minus 3x squared. Then I take the plus x. There's nothing to add with that, so I just say plus x. And the minus 1, there's nothing to add with that, so I'd have minus 1. And this would be my polynomial. It's in standard form already. If it wasn't, if you added the terms in different orders, make sure you rearrange it so that it's in standard form. All right. And that would be 4 terms. It would be to the third degree, a leading coefficient of 3. Not that we have to identify those, but just talk about it a little bit here so we see what that looks like in another example. All right. In part B over here, we're going to add, right, we're adding, so let's add the like terms. So I'm going to add 3x squared plus x squared is 4x squared. X plus 4x is 5x. And then I have negative 6 plus 10, which is 4. And that would be my polynomial. Add and subtract the like terms. Those we're adding. Now let's see what happens when we're subtracting. So I'm going to subtract like terms because I've got subtraction here. The key here is to know that you're subtracting this entire polynomial. Everything after that subtraction sign is being subtracted. So we had to make sure we pay attention to what happened when we were subtracting negatives, subtracting positives. Pay attention to how to work with those different signs on these terms. So first let's start with the 4n squared minus negative 2n squared. So that's 4n squared plus 2n squared because we're subtracting a negative. So that's 6n squared. And then we've got the 2n here. There's nothing over here to combine with it, but it's not plus 2n because it's subtracting a positive 2n. So it's minus 2n. So minus 2n. And then we would have 5 minus negative 4. So it's 5 plus 4 because we're subtracting a negative would be plus 9. So we have 6n squared minus 2n plus 9. That's a trinomial, degree 2 with a leading coefficient of 6. All right. When you're subtracting, important to make sure you know that you're subtracting everything after the minus sign. Everything in the second polynomial is being subtracted from the first one. All right, now we look at our next example, B here. So we have 4x squared minus 3x squared. That's 1x squared. You don't have to write the 1. If you do put a 1 there, it's not wrong, but you don't have to write it. So x squared. Then we have negative 3x minus negative x. That's minus 2x, because that'd be negative 3 plus 1x. And then 5 minus negative 8. So 5 plus 8 is 13. All right, so we have x squared minus 2x plus 13. So we see adding and subtracting polynomials means you're adding and subtracting the like terms, same variables to the same powers, make something a like term, add or subtract the coefficients. Make sure you understand the terminology, how to identify those key pieces of information, know if something's a polynomial, what degree it is, how many terms it has, so we can use that vocabulary properly as we progress through, and we're going to do even more work with polynomials, but starting out here, adding and subtracting by combining those like terms.